This is a capacitor. So is this, and so is this. And if you guys have an AC unit, then you've definitely heard this term before. And in today's video, I'm going to talk to you about everything you need to know, including how to troubleshoot it, how to test if it's bad, and even how to replace it so you guys don't get swindled by a technician ever again. Let's get at it. What's going on, guys? Welcome back to the channel. If it's your first time here, welcome. To all my longtime subscribers, welcome back. Like I said in the intro, in today's video, I'm going to be talking to you guys about capacitors. In my last video, I spoke to you guys about contactors. So this is an ongoing series about your HVAC unit, and I'm going to try and cover everything so you guys can be well versed in how to understand your AC unit, how it works. Now, if you haven't seen that video on contactors, go check it out. Now, as a homeowner, your AC unit is going to give you trouble at some point in time. And by understanding what's going on, you're going to be able to save yourself a bunch of money along the way. And that's why I'm here today. Now, in today's video, I'm going to talk to you guys about what a capacitor is, how it works, how to test it, and even how to replace it if you have a bad one. Now, I've heard horror stories about AC companies charging people hundreds of dollars to replace these things. And to be honest, if you are one of those people and you've succumbed to that, I'm sorry, but this thing is 20, 30 bucks and you should be able to replace it or test it definitely in 10, 15 minutes. And of course, I don't want you guys to fall into the same trap. So let's talk about it. Now, if you guys look on the inside of your outdoor unit, you're going to see two items that stand out to you typically. One is a contactor. We've already talked about that. And the other one is this cylindrical looking thing here. It's called a capacitor. Now, the way this works is pretty simple. When your thermostat calls for cooling, it's going to send high voltage through your contactor to your compressor and your fan. But that's not as simple as it goes. Your fan and your compressor, they need like a little jolt of electricity to kind of jumpstart them to get them running. And that's where the capacitor comes into play. It will deliver that little jolt that is required to kickstart your compressor and your fan, get them running. And once they're running, the high voltage is enough to just keep the momentum going and keep your fan and compressor running. Once your thermostat reaches temperature, it's going to kill the power to your contactor, which is going to kill the power to your fan and your compressor and shut it down. Now remember, make sure you save this video because I'm going to cover everything related to a capacitor. So you guys are going to be well versed by the time this is done. Now let's go ahead and let's talk about how to troubleshoot this thing. Okay, so here's what you want to know first and foremost. If you have your thermostat set to cool and it's calling for cooling, but your fan isn't running or your compressor isn't running outside, then you may have a bad capacitor. But like I said in my last video, you want to test your contactor first. And if you don't know how to test your contactor, please check my video on it. And once you do, you'll be able to understand how to test it and you'll be good to go. So now, once you know that your contactor is good and you want to go ahead and test your capacitor, the first thing you want to do is you want to go over to your breaker or your disconnect box and you want to turn off the power that's going to your outdoor unit. This is very important. You guys, you don't want to be messing around with high voltage and getting shocked. Just take the necessary precautions, turn off the power, and then we can go ahead and get to troubleshooting. Once you turn off your breaker or your disconnect, you want to disconnect the wires that are going to your capacitor. You're going to have a bunch of wires that are connected here, and it's always a great idea. I always tell people, take a picture of this so that you know exactly what wire goes where. Once you know where all your wires are going, the next thing you want to do is you want to disconnect all your wires. Take a pair of pliers, needle nose, and pull the wires off that are connected to the terminal on your capacitor. I can't stress this enough. The next step is very important. Before you guys go ahead and start testing this thing, you want to discharge any voltage that may be stored in your capacitor. These things may hold a charge, so before you go testing them, let's discharge them. And discharging them is pretty simple. You want to grab yourself an insulated screwdriver like this one. So what you want to do is you want to grab your screwdriver and you want to touch it to two of the terminals at the same time. So you touch them to these two, then you can touch them to these two, then you can touch them to these two. Once you've done that, your capacitor is completely discharged and you're good to go ahead and troubleshoot it. Now remember, you don't have to take it out of your unit like you see me here. You can test it while it's inside your unit, but if you want to, you can pull it out. The first thing you want to do is you want to take a look at your capacitor and look at the top. Now the capacitor should have a flat surface like this one here. As you can tell, if you guys have a little bulge or you see it bulged at the top, then you know that your capacitor is bad. Go ahead and replace it. You can skip any of these steps. Just go ahead and change your capacitor. There are several types of capacitors, and as you can see here, I have 3 different styles. One has 3 terminals, another one has 3 terminals, and this one has 2 terminals. This one is color coded, this one is not. I'll talk to you guys about what each one does and how to differentiate them. This capacitor with the 3 terminals is called a dual run capacitor. Why? Because it controls both the fan and the compressor in your outdoor unit. This one just has 2 terminals and it's just a regular capacitor, and it will control one device, either your fan or your compressor. Now, the first thing you want to do before you test your capacitors, you want to know what size capacitor you have, and it's pretty simple. As you can see on mine, it says 45 plus 7.5 microfarad plus or minus 5%. This means that one of the leads is going to read 45 microfarad and the other one is going to read 7.5 microfarad. Now let's go ahead and turn on your meter and set it to capacitance. Now, not all meters have a capacitance reading. If your meter does not have this, I do suggest get one. They're very inexpensive now. I'll leave links in the description if you want to get the one like what I have, but there are many out there that will have this reading, and you'll be able to use this to read your capacitor. Now you want to go ahead and set it to capacitance. As you can see on mine here, it's this little symbol that's looking right here. All right, once you have it set to capacitance, before you test your capacitor is, if you notice, I have 3 terminals here. One is labeled C, one is labeled F for fan, and one is labeled H for Herm, which is your compressor. They may vary, some of them are color coded, but they all serve the same purpose and they'll all be labeled as such. Now, if you don't have any labels on your capacitor, the first thing I want you to do is just take a note of the amount of terminals that are on your capacitor. Now, if you notice, this one has the most, which is 4. Your common will always have the most terminals. The port with the second most terminals is going to be your compressor. And lastly, the one with the least amount of terminals is going to be your fan. Now that we have our meter set, we want to go ahead and place one of our probes on the C terminal. And what I want to test first is I want to test the fan. So let's go ahead and put the other probe on the fan terminal and hold it there for a second. You want to let this thing register and your meter should give you a reading. And as you can see, mine says 7.59 microfarad, which is within the allowed tolerance, which means that the fan side of my capacitor is good. To test the other side, you just want to do the same thing. You put one port on the C terminal and you can put another lead on the H terminal. Let it sit and look at that. It's reading 45.31 microfarad, which means that this capacitor is good and it's within the bounds of what it should be. If your capacitor only has 2 ports, like this one here, what you want to do again is take a look at the reading, and on mine it says 12.5 microfarad plus or minus 5%. Now what you want to do is put your leads on either one of the ports. It doesn't matter what terminal you put them to, but what you're looking for is 12.5. So what we do is we'll put one on one, one on the other, and we'll just wait for our meter to read. And like you see there, it's 12.62 again, which means that this capacitor falls within the tolerance of being a good capacitor. So you've tested your capacitor and it's bad. So what now? Obviously, it's time to replace it. And replacing this thing is super easy. Do not let a technician charge you hundreds of dollars to do this. If you have a bad capacitor, you can change it yourself. What I do recommend, and here's a good tip, is once you have your AC unit, if you're doing maintenance on it and you take off the cover for the electrical panel, take a snapshot of the label on your capacitor and go ahead and order one and keep a spare one in your garage or wherever you want to, just in case one of these things go bad. They will eventually. You can go ahead and replace it and you don't have to worry about calling someone. So now if you've tested the capacitor and it's bad, what do you need to do? Replace it, of course. It's pretty simple. All you need to do is take the old one out and do a quick Google search and find one that matches your existing one that's already inside your unit. Once you have the new replacement, you want to go ahead and take the old one out. You've already disconnected the wires, and it's usually just held in place by a screw and a strap. Loosen the screw, slide your old capacitor out, slide the new one in. Now, sometimes the new ones are smaller than the old ones. In my case, this is an original one that I had in one of my units, and this one is the same specs. However, you can clearly tell one is much smaller than the other. So if you have this scenario, usually you can adjust the strap, tighten the strap, and put the screw in, and you're good to go. Now, once a new capacitor is in, all you got to do is reconnect all the wires. If you took a picture, then you're good to go. You know where everything goes. All you need to do now is connect all the wires as they were originally. Close up your electrical panel, turn on your breaker or your disconnect, set your thermostat to cool, and you should be good to go. Your system should be cooling like normal. All right, so now you guys know how to troubleshoot, test, and replace your capacitor. And if you don't mind, please remember, leave a comment below and tell me if you've replaced yours and if it went smoothly, or if you have any other tips for me that you guys like to use whenever you're replacing your capacitor. Or better yet, let me know any horror stories that you guys have about technicians or about trying to replace one of these things. Once again, thank you guys so much for watching, and until next time, I'll catch you guys in the next one.